Hello everyone, welcome to Engineering Bookshops. So for this video, we're going to solve problems on our Engineering Mechanics Statics textbook. So it's all about chapter 1, vector multiplication. So I'm going to solve problems 1.57 to 1.59. So just keep on watching guys, and let's start. Alright guys, so for problem 1.57, again guys, you must have the copy of the textbook so that you will know the problems that we will be solving. So for problem 1.57, we have to find the dot product AB. So these were the formula that we will be using for us to solve the problem. So for letter A, we have to find the dot product A dot B. So as you can see of the problem, there is 0i for A, and then there is 7i for B. So 0 times 7 plus there is 6j for A and negative 3j for B. So it is 6 multiplied by negative 3. And there is positive 9k for A and positive 2k for B. So that's why it is 9 times 2. And we have our answer. So 0 times 7 is 0, 6 times negative 3 is negative 18 plus positive 18. So therefore AB is equal to 0. So for B, it's just the same. So we were just going to multiply our data. So 2 times 6 plus negative 3 times 0 plus 0 times negative 3. As you can see, this is 12 Newton meter. And for C, AB, 5 times negative 5 for J. For I, plus negative 6 times 8 for AB of J, and plus negative 1 times 6 for AB of K. And there we have negative 79 m squared. So the unit for A, guys, here is m, and the unit for B here is n. That's why it's Newton meter. And this one, both units are m. So that's why it became m squared. So for problem 1.58. So in this problem, we have to find the cross product C equals to A times B. So for us to solve this problem, we must be familiar with this cross vector product. So for this one, what we are going to do is, so for I, we have to cross multiply this column J and K. So AY times BJ minus AJ times BY. So that is for I. And for J, cross multiply of column I and K. So AX times BJ minus AJ times BX. And then for K, so this one, so AX, so plus, then AX times by minus ay times bxk. So to solve for our problem 1.58, our given data is from problem 1.57. So this one. So for A, we have 0, 6, and 9. And for B, we have 7, negative 3, and 2. So to solve this, so for I, 6 times 2 minus 9 times negative 3. And then minus for J, 0 times 2 minus 9 times 7 J, and then plus for K, 0 times negative 3 minus 6 times 7. So here our cross vector product A times B will be 39i, since 6 times 2 is 12, and then plus 27 is 39i, and then 9 times 7, so this will be positive 63j and negative 42k n squared. So for letter B, same. So 2, negative 3, and 0, and 6, 0, and negative 13. So we are going to use the same, to do the same. So for I, negative 3 times negative 13 minus 0 times 0, so I, minus for J, 2 times negative 13, and 0 times 6 is 0, so that's it. So for K, 2 times, so plus 2 times 0 minus negative negative 3 times 6. Okay? So therefore, we have negative 3 times negative 13 is positive 39. Then negative 2 times negative 13 is positive 26. And negative times negative 3 times 6 is positive 18k. Okay, so we have our answer for B. And for C, so we have 5, negative 6, and negative 1, and negative 5, 8, and 6. So for this problem, for I, so negative 6 times 6 minus negative 1 times 8, I, then minus, for J, so 5 times 6 minus negative 1 times negative 5J, and for K, plus 5 times 8 minus negative 6 times negative 5. So we have this answer. So negative 6 times 6 is negative 36 plus 8 is negative 28. And then minus 30 minus 5 is negative, so negative 30. And then this will be plus 5 is negative 25j, and then 40, then minus 30 is positive 10 kn squared. So that's it for our problem 1.57 and 1.58. So for problem 1.59, so for us to solve this problem, we must know and we must be familiar with the scalar triple product. So here in scalar triple product, it is ax times quantity bycx minus bjcy minus ay bxcs minus bycx plus az quantity az bycy minus bycx. So here to solve our problem, so on our data, we have for R, we have 5i, 4j, and 3k. For F, we have 30, negative 20, and negative 10. And for unit vector, we have 0 0.6, 0 for I, 0 0.6 for j, and 0 0.8 for k. So for us to solve this, so it will be 5 multiplied by negative 20 times 0 0.8 minus negative 10 times 0 0.6, then minus quantity 4 multiplied by 30 times 0 0.8 minus negative 10 times 0 is 0, and then plus 3 quantity 30 times 0 0.6 minus negative 20 times 0 is 0. And here we can solve for our R times F. R times F dot unit vector. So it is negative 92. So to compute, it is 5 times negative 20 times 0 0.8 minus negative 10 times 0 0.6 minus 4 quantity 30 times 0 0.8 plus 3 times 30 times 0 0.6. So the answer is negative 92 Newton m. So for unit vector times R times F, so looking at this formula for this one, so therefore our unit vector times R dot F is also equivalent to negative 92. But still, I will show you how to solve that one. So it will just like this. So for unit vector 0 0.6 and 0 0.8, and then for R it is 5, 4, 3, and for F it is 30, negative 20, negative 10. So it's just like the same. So 0. For this is actually 0 already because 0 multiplied by the cross multiply of this one is actually 0. And then for this one, so 0 0.6 quantity, so minus 0 0.6 quantity, 5 times negative 10 minus 3 times 30, and then plus 0.8, 5 times negative 20 minus 4 times 30. So by okay, so let's compute. So negative 0.6 times 5 times negative 10 minus 3 times 30 plus 0.8 quantity 5 times negative 20 minus 4 times 30. So it is negative 92 and meter.